So I love event-driven architecture and domain-driven design. How I got into event-driven architecture is I used to work for a company whose core domain was sending regulatory notices or letters to homeowners when they lost their homes. And in 2009, when the whole real estate market crashed, it was really bad. And so lots of, so the company made money because the business was sending all these letters, and there was a huge amount of people who lost their homes. So that was a core business. And so the software, when I joined the company, it was doing okay, but at the time, the load was a lot. So they were trying to figure out how to scale it. And that's kind of what led me into event-driven architecture. And domain-driven design, for me, was it's not just writing software. We're all here trying to write software to make our businesses grow and be better. But it's like, how can we write software that if we align our code and our design to what the business is actually trying to do, we can build features and faster and grow with the complexity, help business figure out experiments that they want to try to run, and really help them. So our job as software engineers and architects is to help the business grow. So that's where domain-driven design kind of fit nicely. So combining event-driven architecture as a way of communicating between all these different software components was really awesome. So Jay already told me a little bit. I am a solution architect. I work for a particular software. Particular software makes NServiceBus. And who here has used NServiceBus? Oh, a lot of hands. Cool. So you can always find me and some of my colleagues who are here later. So I will not be talking a lot about NServiceBus. This talk would be strictly about design and architecture. So when we try to design something, we typically start out with a mock-up of a UI, and we kind of look at it and go, okay, what are all the things? So this screen has a picture of a phone case, name, description, price, something about like shipping, etc. So if we're trying to model all this information, we kind of start thinking in terms of entities, and then we come up with a model, and then we attach all these attributes like the name, description, etc. So we have all this because it's years and years of practice, right? Object orientation taught us, hey, look for the nouns, and those nouns turn into classes, and then we start modeling the structure. And then we start looking at the structure and go, oh, okay, this object has these relationships. So we start going deeper and deeper, and we don't really pay attention to the actual behavior. And that's the most important part, the behavior. I mean, good object orientation said it's not all about just the attributes, it's also the behavior of the object. But we take what's easy and kind of like shove away the things that are somewhat difficult. So so we tend to model these things, but what really is a product? Well, a product can mean different things to different people. For somebody that's working in the sales, it's something that they're trying to sell. So when they refer to as product, they're more concerned about, how marketable is this thing? Am I, do I have good descriptions of it, and running campaigns and things and so on. But for somebody in the inventory, it's like it's something like, how much do I have? Do I need to get more of? And making sure that this thing is available on the shelves for me, for the user. So, and for somebody in shipping, it's a thing that needs to get from one place to the other. So even though different people call this as the same, it really depends based on the behavior. It belongs in completely different areas based on the rules and what different people are trying to do. So when we end up modeling as like this one single, entity, or we come up with a unified model to represent what we're trying to do, it starts to get complex over time. It becomes unwieldy. There's duplications, there's contradictions. For example, like you have a team, and there's something called as weight. And for the sales team, it's like the actual weight. If you're like Apple, they're trying to tell you our laptop is so light, just so that's the weight that they're concerned. Whereas somebody in the shipping, it's the weight of the actual box and how much it weighs. It's everything put together. So when you have something like weight in your model, and then you have two different teams looking at that and go, our model already has weight. So then you have one team using that same attribute or property in different ways, and then in production you start to get like weird bugs where it should be the actual weight, you're showing the display weight. So then we start to get these contradictions, but we can fix those contradictions because we're awesome. So what do? We start to put things like, hey, display weight and actual product weight. And so we start adding these clear indicators to those attributes. Now your model starts to grow. And not only that, the person in the shipping team or the sales team, they called it weight, but now your code calls it display weight or product weight. So now when you're actually talking to your domain expert, you've got two different things, and you're like trying to translate this in your head. What's weight means like product. So it gets a little, the whole communication becomes even more complex and complicated. So this is where domain-driven design, like if you read part 4 of the Blue Book, where Eric talks about the strategic design, he talks about bounded context, and he talks about why, for a complex system, you cannot have a unified model. So a bounded context, in my opinion, it's a safe space. So you've got each of these teams, or so in this space, you can have a model that's completely, entirely different from the other team. And in this team, for the sales, weight actually means the display weight. You don't need to have any qualifiers or anything. Your models are much more clean, and it uses the language of your domain experts. So by having this sort of clear boundaries, you have clarity in the language, and you have freedom also to change things. So if the other team in shipping wants to do something, they don't have to wait or look at the schema of the other models in the other context. They're free to evolve their models however they want. So it gives them freedom. So you could evolve both those contexts simultaneously. So it has that ability. Now, so the question then becomes, how do you find the boundary? And that's always like the difficult part. Like, so there's all these things. How am I supposed to know what goes where and what belongs in my context and what doesn't? So so you can use different heuristics. One thing like I've used, and it's helped me in the past, is I look at my model and I ask myself, okay, in this case, this description and the stock availability. Would there be any point in time where we would need to have transactional consistency? So would you ever be updating like the product description and the availability in the same transaction scope? Would there be any rule in your business that says like, oh, when you update like the availability of the stock, the description has to be iPhone 11, right? It doesn't happen. So if you don't have something like that, you shouldn't be like having these two things in the same, model. So that's a clear indication that tells you, hey, these things actually don't belong together. So you could like start weeding those things out. The other way that you can use is to kind of model along the teams. If you already have a set of teams or departments that are doing some things for the business where they're governed by rules and there's some clear processes that are, that they have to follow, you can start there and try to see, what things go together and try to model the actual business behavior. So, in this example, like you've got product as the model. In different departments, there's sales and shipping. So again, like dimensions, even though it says dimensions, it can mean something completely different in sales versus in the shipping or the other context, and that's okay. So by having these different bounded contexts, it gives you ability to use the same language of the domain. So we want to use in our code, in our models, in our design, the language that is being used by product owners and domain experts. So, so if the whole idea for us is to extend with the business, then we can't afford to have all these extra translations in our models and our code to the language that the domain experts are using. So the other way is you could look at the actual business behavior or the business process that's happening. And in this case, like, if you apply for Amazon Prime, you're going to get some magic discount. So there's some process where if there's some credit card whatever process, and if you apply, that discount gets fed back to shipping. So obviously, there's a lot of interconnections, but if we look at those rules and we can follow along like what needs to have the same transactional consistency and try to keep those things together. So this will help us evolve with our business. And that's really our goal. We're all here to learn different ways of how we can model things so we can write efficient, better software. So if you want more information on like finding boundaries, what goes together, Udi has like several talks and videos. Particular software, my company has given access to one of his videos, so you can watch it when at your leisure. So now, so we talked about, we can't afford to have a big, giant model to rule them all. We all know what happens when you have something big to rule them all, right? So either be it a big, giant database or one ring, etc. So we understand that we need different contexts where things can evolve. So we all understand that. So how then, if these are islands of things, doing its own stuff, but as a system as a whole needs to be cohesive. And so, which means that these different parts or bounded contexts or however we have these islands actually need to talk to each other. And that's where, for me, event-driven architecture and messaging comes in. There's different ways of how you can communicate, but if you start using event-driven architecture, you can do so in a way that's loosely coupled, and you can have reliability and have them be autonomous. So for me, that's kind of where messaging comes in nicely with DDD. So when we talk about messaging, there are two important classes of message: commands and events. There's a third class, which is queries, but we're not going to go into that in this talk. You would find a lot about that in any CQRS-related talks. So for the purpose of this talk of communication, let's talk about events and commands. Events is something, it's a message, but it's a fact. You only say when something has already happened. And usually, these are very, very significant things to the business in the business flow. So it's not, when we're naming these things, when we're calling them, we want to use the past tense verb to indicate them. So something has happened in that fashion, because you want to clearly indicate that this is a fact. Because when you publish that fact, there could be so many other listeners to this event that could go start making their own actions based on this. So once you publish this event, you can't go take it back and say, oh, sorry, that never happened, because now there are already downstream processes that have started acting upon them. So you only publish events after they've happened. Also, events, you could have multiple subscribers to these events. Now, there's an interesting thing about events, which is once you publish that, whatever information you publish, it's stale. So you want to keep that in mind when you're modeling it, that you're taking action based on something that's happened in the past, and you're going off of that context. So if you know that this information is stale, then you can start asking questions like, hey, what happens if I don't get this event? And how long should I wait? Or if, let's say, there's an event called Customer Became Preferred, and now you're offering discounts based, there's another whole business process that's offering discounts based on the fact that the customer is preferred. At some point, let's say the customer is no longer preferred. What then? This side or this part of the process is still giving them discounts because it hasn't heard about the fact that the customer is now no longer preferred. So how long is that okay? When is it not okay? Well, we as programmers and architects can't make that decision. These are decisions based that need to be made by the actual product owners and the business owners, because they understand the risk. But when we understand the staleness, we can approach them and ask, hey, what is the risk of us offering the same discount to this person? And if the risk is like, oh yeah, no problem, just go ahead, then there is no problem. But if there is an inherent risk, you bring those conversations up, and so based on that, you can model whatever the consequence needs to be in your software. So on the other hand, commands are something that are imperative in nature, they're action-oriented, and commands can fail. And commands are usually sent to one listener or receiver, as opposed to events that are being broadcasted. So these, to me, you can use commands as a way of messaging within a bounded context, but you typically don't tend to send commands to a different bounded context to tell them what to do. I mean, bounded contexts listen to each other's events, but you can't tell one bounded context, go do something, and that's not a good pattern or a good design. It's very, very useful when you're using it within a bounded context where you're breaking up your work into like asynchronous workflow, and so you're sending a command and letting offloading that process, for example, like credit card payments, or where you need to talk to a third-party API or something like that within a context. So it's nice to do it asynchronously. By sending a command, you're also reliable, and you can have things like, if there's any technological failure, for example, the web service is down or the database is down, you can, by having it sent as a message, you get all the reliability of using messages by, having the receiver automatically retry the message, and if not, save that message later as a poison message, etc. So you get all those benefits of using messages. So commands are quite useful in that sense. So now let's take an example. Let's say that so this is I picked this example because I was flying to one of our company meetups, and I was flying to Rome, and then all of a sudden I got an email from Norwegian Airlines saying like, oh, sorry, your flight's changed, and now you've got an option. You either, here's your new proposed route. You're gonna, fly out of Copenhagen or whatever, stay there for instead of a direct flight, etc. So I have this option to either accept their new proposal, or I have this option to say, you know what, I don't want to, this new route is like so awful, just give me my money back. So this is, let's say this is a use case. By the way, this is the email I got. So if we take this example, a business process could be triggered by an event from another context. So in this case, the flight planning context is the one that says like, hey, aircraft type has changed. So it publishes this event. Now, all of a sudden, the booking context is very, very interested in this event because it's going to impact a whole lot of people who are flying on that aircraft. So the thing about here is like, you know, we're publishing these events with this whole notion of like, hey, it's great, and these messages, and we're using messages because we want to be loosely coupled. We have to keep in mind what you put in those events are very, very important. It's easy to like put in like a whole lot of information, and now you're going to be coupled based on the schema because both the sender and the receiver needs to understand the same schema for these messages. So when a bounded context publishes events, I used to call them public events, but somebody had a better name for this as integration events. So you could think of these public events or integration events as special events that go from one bounded context to many bounded contexts. So when we know that, we have to be very, very intentional about what we put in those events. So one way to think of is like, hey, what can I leak from my bounded context? I use the word leak because it's not a nice term. Like nobody likes leaking data, or you know. But so if you think about it that way, you'd attach more importance on like to keep it very minimal of what you want to put in those messages. So ask yourself, like, what do you want to intentionally leak from that context? So that's the information that's going in that event. Otherwise, you know, the whole nirvana of like loosely coupled systems and having less dependency goes out the window, and now you're going to be in schema hell, you know, of trying to, and your schema is going to grow like the unified model. So that's something to keep in mind. Now, when this context receives this event, there can be multiple messages that take part in this activity. So when the booking context receives this event, it can kick off many, many things. It can send a command internally to accomplish something. So there could be many, many messages that partake in this business behavior. So like passenger in this case could cancel and say, hey, give me my money back, or so on. So how do we deal with when we have multiple messages and we're looking at like an outcome based on this? There's usually state involved, because when and that's where the Saga pattern comes in handy, because of state. One message, whether you send out, whether you give the customer a refund or not, is dependent on the fact that, you know, they've said like, give me my money back. Or you might not give them a refund. You might give them whatever your proposed booking was, because, you know, they didn't respond to you, or they said your new proposal was okay. So the outcome is going to be different. So how do you take these outcomes? That's going to be, you know, dependent on the state. So a Saga is a useful pattern where when message comes in, you put something internally. The state here for the pattern is very private. It's not like a separate database or the business database that you're using. It's very private and very, very internal. So in DDD, I mean, this is also referred to as the process manager, if you're more familiar with process manager. There's a whole debate about, should we call this Saga, or why is this even called Saga, and this should be a process manager? That's a whole different debate that I'm not willing to get into, depending on which community you talk to. So the important thing is, Yes, so process manager or Sagas, when you have multiple messages involved trying to do something and where you're trying to compensate, you're going to have state. And the Saga is also useful to take compensating actions. So a lot of times when we're focused on finding events, business also needs to know when something hasn't happened. And that's something that's very, very useful to know. And that's kind of where you can model time, where you can use time as a message and say, hey, I want you to wait for 24 hours or 48 hours and then wake me up or remind me when this time has elapsed. So all these sort of time elapsed events could also be modeled as messages. And based on that, you might compensate differently. So this pattern is useful. As with patterns, there's always cases where you don't use them. So if you're like modeling like a flow like McDonald's where there's a specific action that happens and then like, fixing up the lettuce and stuff, and after that you go to the next process where the meat is being added. So if you're going from step A and then to step B and then step C, you don't need the Saga pattern because Saga pattern is like an orchestrator. You don't want to add a lot of extra contention, saying like, oh, step 1's done. I'm going to tell the Saga. Now the Saga is like, oh, go do step 2. And so you're going to add a lot of extra replies and stuff back to your Saga. So in that case, a routing slip or itinerary pattern is better. So in some cases, you don't even need Sagas. You can use a messaging pattern publish, subscribe, as a way to cascade business behavior, where one context publishes an event, and that's good enough to trigger a whole other process in this other context. So you don't need Sagas. It could just happen by way of publish and subscribe. So how do we model business flows and processes and business behavior? And this is where event storming comes in. Alberta could talk to you for 2 days or even more, but so this is a great collaborative way of trying to understand the business behavior. If we want to write code that reflects business behavior, then we have to talk, whether we like it or not, to other people who have the answers. So event storming is a technique where we bring the experts who know the answers into the same room, and along with architects, programmers, even QA, because whoever the valid stakeholders are who are trying to understand the process, bring them to the same room. And the idea here is we want to visually collaborate and visually indicate the business flow, where our whole goal is to understand the behavior and the risks. So that's kind of what we're trying to use this process for. Just as a importance of collaboration, I once worked at a company where we were doing this project. So there was this manual flow of approval that this one person was doing. So she would get emails from the customer and then go back and forth and say, is this look okay? And the customer would say yes or no. And so it goes back through several iterations. So the company wanted to automate that. So there was a developer allocated to that project, and there was a UX designer in New York, so drew fancy boxes, and so there's a whole bunch of iteration between the developer and the UX person, and then the software got built in a month, and then they gave it to her, and she said, this is crap, I can't use it. So someone forgot to, or she was a stakeholder who knew a lot of stuff about that process and that domain, but she wasn't involved in that discussion, so we lost like a whole month, and there was a kickoff for version 2 of the software and so on. So collaboration is important, and like when we talk to different stakeholders, that's when we're going to know what the business actually wants. Yes, our job is to write software, but our job is also to write the correct software for business. So this is where, for me, like watching event storming or even doing event storming was like super awesome, because it just gives a very nice way of collaborating as people. And like what I found is like when you're sitting in a very traditional sitting or a traditional meeting, you know, at a table, and you're sitting across from each other and you're working through the problem, like oftentimes it's like you're this person, you're dying to speak out, but there's this other person who's taking forever, and you're waiting your turn, and sometimes you don't get the opportunity, your idea gets missed out. So, and that could, you know, cause a whole bunch of distractions as well, because now you're so focused on your, I don't know, it's happened to me, you're so focused on your thought that you're not paying attention to like what's being said, because like you really want to get your idea out. So event storming, there's none of that. And I have an idea and we're all talking, so I just take the Post-it note, write like what I think, and go post it on the wall. So it right away, like, you know, diffuses that conflict. So it's a great way of just collaboration in general. I've used this just technique as a way in our own company meetup where we were trying to answer a question. So we just put it up on the wall. This is a question that we're trying to answer. What are the risks of doing it this way? What are the risks of doing it this way? And so we were able to just model it and come to an answer. So it's really awesome. So how do you use event storming? So if we take that same business case and try to model it, so we have aircraft type has changed event. So we try to, as a first step, try to figure out what are all the most significant events that are happening in this business flow. So we go, okay, we've got, we're modeling, so we're trying to find all the events, and sometimes it can kind of tell us, oh, this is coming from this context. So maybe we denote them from, you know, different sticky or different color or something to say, hey, this event, this is an integration event that's coming from a different bounded context. So okay, we do that. And the next step is like, okay, so once we do that, we want to see, like, are there any commands that it generates? So it's kind of hard to see. So aircraft type has changed. So once that happens, we want to rebook the flight. So once we rebook the flight, we want to notify the customer and about the change. And then we want to wait for X number of days for the customer, for the passenger to respond. And based on that, we either confirm the booking or, you know, they cancel the booking. So we cancel the booking and we publish an event. So we translate that to code. So there's an event, there's a handler for that event. So you write code. So each of these events get translated into code. You've got nice message handlers for this, and you've got for the things that, you know, work together for the multiple events. You've got the Saga pattern. You have your code that implements the Saga pattern, takes the compensating action, and so on. But so what's the hard part here? Well, finding the actual name of those events are really hard. We're so used to the CRUD model of working, and so we always are thinking in terms of created, updated, deleted. I mean, so we want to use the right names. So we tend to call customer was created, or sometimes we use like technical language for those events. PDF document was generated. I have done this before. It's not a very nice name. But that doesn't mean anything to the business stakeholder. What PDF? Like what document? Whereas if we say the regulatory letter was generated, that means something to the business. And based on that, they know, okay, once you generate this letter, there's a whole other process happening. So the names are important. So even in this example, you know, first I wrote this code, and then I looked at the language again. It's actually, you know, the language is very clear. It's a booking proposal. And yet, what I had called it was like, you know, rebook flight. We're not rebooking flight. We're actually proposing a booking. So when you find discrepancies in your language, like, you know, fix that. Like you refactor your code and you know, use the right language. And when we start out, we are going to make mistakes, and our models are not going to be perfect, but that's okay. We don't have to be perfect. We are always evolving. How we evolve is through the constant communication with the domain experts. We figure out what is the right language they're using, and then we use that language, go and change the messages or event names. If they're no longer accurately representing, then fix them, and constantly evolve, because if you're using the right language and then they give you a new requirement, it's much easier to fit in because you're calling the right events, and so you know where exactly does this fit in your existing model. So it's really important to do that. Also have, as Matthias likes to call it, have a very healthy obsession with language. I've watched enough of his talks, so I'm borrowing the term. Have a very healthy obsession with language. So I used to do this all the time. I have an event, I attach a handler to it, and so that's the class name. But handler is like, what is it? It's just an implementation detail that doesn't tell you anything. And aircraft type was changed, that was the event. But the class, what it's actually trying to do, is like, much more. So try to actually, this sounds like very basic and fundamental, but like I used to do this all the time. Just whatever event, handler, instead of like using proper name to establish the intent. So same thing, I used to call all my Sagas policies, but instead, what is it actually trying to do? Is it a grace period for accepting rebookings? Is a much nicer name than booking policy. So, and then the other thing is make messages immutable. Messages are immutable. Once you publish an event or you send a command, the receiving party or listener cannot change those. So make that very explicit in your code. So the other thing that I want to quickly touch upon is, this is great, and let's say we now say we want, we get a new requirement that says like, hey, but we don't want to constantly notify all these economy class passengers. We only want to notify the paying ones, the ones who pay a lot more money. So so if we want to do this, there's several ways. So one way is like, now you're in a situation where one context needs data from a different context, because the loyalty context is the one who knows whether the customer is preferred or not. So what do? So you could do this where you ask the context for the data, but then if you do this, then you're temporally coupled, and which means that if for whatever reason loyalty isn't around, if they're doing any maintenance work, your booking context can make decisions and proceed with the booking. So you are coupled, and so this is where you can use publish subscribe as a way to diffuse this temporal coupling, where loyalty, whenever those events happen, they publish and saying, hey, customer was promoted to gold or platinum. Now booking context can simply listen to those events and keep track of that internally, and when it receives the aircraft type was changed, it already has data in its own context to make decisions on whether to offer or to send an email or not. So you can use publish subscribe as a way to make autonomous decisions. So when you do this, your deployments become much simpler in the sense of you have these modules. Now you are in a way where you can make these business experiments, so to speak. So if the domain if the business wants to try out a new promotion or something new, or you're not sure, so you can just introduce like your second variation of what that behavior is, and have those messages. Some of them go to behavior 1, some of them go to behavior 2. See how it works, and if the business likes the idea, then you go with the new way. You don't have to go in and like start changing existing code. You could build this in such a way that these sort of experiments are very feasible. So if you're just doing like a simple versioning, what you do is like, okay, so once you make sure that your newer version's working fine, you shut the old version down, and you're good. But life always doesn't follow the happy path. Sometimes, when we deploy something, it can fail. So if it fails, then those messages don't get lost. They simply get routed to an error queue. So what happens is, okay, you then know that, okay, this is not working. So you stop your the module that's not working, and you take the messages that is in the error queue and send it back to the original version that's still running, so your business isn't interrupted. And then you go fix the original service, and you follow the same process. So the most important thing here is you have to talk to the domain experts. They are the ones with the answers, and we want to try to model all the business the risks in our code, because if we don't do that, there's no way we can write software that evolves with the business. And even with the same aircraft example, we did this as a workshop yesterday, and it sounded so simple. It's just 3 lines of requirements. But then once we start thinking and asking, hey, because people pay for aircraft seats now, so you could have specifically requested an aisle seat on the left-hand side of the plane. So when this aircraft, change arrives, you need to make sure you're seating, on the newer aircraft on the same side. If you can't, what can you do? And that's not something that we can decide. That's something that we have to ask the company. Hey, is that okay if we reseat them as long as it's window or aisle? So those are the complex questions that we have to ask the domain experts, and those sort of things, if we don't ask, we're not going to find. So our models will not be perfect, and that's okay. Our job is to try to model business behavior as closely as we can, and that we can only do that by constantly evolving our models and by constantly having collaborative sessions, and have an event storming session once things are working. Make sure that that's kind of is the expected behavior. And maybe once you do an event storming session of your current software that's working, maybe the domain expert might go look and say, wait, why are you doing that over here? It should not behave that way. And those conversations are important because they help us identify where our code and models are diverging or already has diverged from what the business is actually asking us to do. So that is super important. And also, use messages as a way of communicating between bounded contexts because they give you the autonomy and reliability. But when you're using messages, do be careful especially with those integration events, of what you're publishing in those events and sharing across bounded contexts. And you don't want to be coupled in a schema hell. So thank you so much.